When we're presented with new information, we process it in our working memory. This is called essential cognitive processing. The more complex the material, the more essential processing needed. However, essential processing alone is not enough. We still need to engage in deeper processing for us to be able to transfer what we learned to a new context. When that deeper processing doesn't happen, then we might be able to remember isolated bits of knowledge, but not know why they're relevant or how to apply them. For example, if you've watched all the videos in this multimedia learning series up to now, you might be able to remember the names of all the principles discussed so far. If you took a retention test where all you have to do is remember the names of the principles, you might be able to do pretty well. However, if you were asked to transfer your understanding, for example, by making your own multimedia content based on these principles, or by explaining how and why all these principles work, then only those of you who truly understood them will be able to do so. But essential processing can itself lead to cognitive overload, especially if the material is complex, if the learner is new to the topic, or if the presentation is fast-paced. The segmenting principle helps prevent cognitive overload at this stage of learning by breaking down complicated material into smaller, more manageable chunks. Another thing that would help is if learners have control over when the next segment is presented, allowing them time to process one segment before going to the next. This would be best implemented in a self-paced multimedia module, which you can easily design using applications like PowerPoint, Google Slides, and Keynote. A series of studies showed that following the segmenting principle had a positive effect on learning. In one study, a group of students were shown a continuous lesson in which students were presented with the entire lesson without control over its pacing, and another group was presented with a segmented lesson, with a continue button below to let them advance on their own. The segmented group outperformed the continuous group with an effect size of 1.13. In another study, the segmented group was presented with 5 questions that explain how motors work, and by clicking on all of them, they will receive the same lesson as the continuous group. The segmented group outperformed the continuous group in an immediate transfer test, which is a test given right after the lesson, with an effect size of 0.82. They did even better in a delayed transfer test, which was given a week later, with an effect size of 0.98. Segmenting can also be designed to show different layers of information. In one study, students were presented with a graph on erosion that showed different variables. The control group was presented with the entire graph and were allowed to view it for as long as they wanted. The segmented group was shown the graph in successive steps, starting with the x-axis, then the y-axis, the lines, and the colored areas. Both groups were asked to write down descriptions of the graph and the relationship between the variables. The segmented group in this study outperformed the control group with an effect size of 0.60. However, there are limits to the segmenting principle, especially when students come with different levels of prior knowledge. In a study involving 8th grade math students in Australia, students were presented with a worked example of a math problem. The control group was shown this example. The segmented group was shown this example with one computation shown at a time. Students who came with more prior knowledge benefited more from being shown the entire worked example, while students with low prior knowledge benefited more from the segmented lesson. This is known as the expertise reversal effect, which is something that's been mentioned in the video on the multimedia principle. The segmenting principle is also shown to benefit in teaching with simulations and in documentaries that are broken down into segments, with signaling added, and with entertaining but irrelevant content removed. As an instructor, you're likely to have a group of learners who come with different levels of prior knowledge. Instead of picking between segmenting your lesson or not, perhaps you can create some segmented modules that students who need them can review at their own pace. The segmenting principle is pretty straightforward. Like many of the other principles, they do require a bit more work to design, but once you do it, you can reuse the same template with other lessons, and it becomes easier over time. Having these modules ready can also let you more effectively differentiate between learners with different levels of prior knowledge.